important. The next thing that we are going to talk about is this term, which is a strange term. We have never seen this term before. Okay? We could have an understanding of this of a relative, but why do we have this extra term? Okay, this A relative is due to the relative motion of A with respect to this frame. That's understandable, but why do we have this term? This term only exists if there is this rotation of the rigid body. Okay, so let's be clear on that. And then there's a relative motion of A, or the point of interest. To investigate what this is, we can take a look at this example of this disk, which has this slot here, and on that slot there is this piece of point A moving back and forth, and its motion is defined from point O. This is the rotation axis, okay, from point O with this x, and x dot is defined to be constant, so x double dot is equal to 0. That means x double dot is equal to 0. And then there's this omega defined as constant. There's this constant rotation of this disk. That means omega dot, which is equal to alpha, is equal to 0. Now, we can apply our knowledge about the relative velocity information. The absolute velocity of A is equal to absolute velocity of O. O is a fixed point, that's why it's equal to 0. Plus omega cross product R plus V relative. Now, V relative is the relative velocity with respect to this moving frame, and this slot is in the x direction. So V relative will be in the x direction, and it will be defined as x dot, and its direction is always in the I direction. So this is the V relative information. Then there is this omega cross product R. Omega is in the k direction, which is the z direction, xy axis. This is z direction. Cross product x in the I direction. This is the location of A point with respect to O in its own frame, xy frame. This is small caps xy, so it's in the xi direction. Omega cross product xi. And the resultant of this is k cross product I is j, so this is omega x in the j direction. That's why we have this x omega in the j direction. Then we're going to take a look at the change of this information, change with respect to time, right? So we can investigate this similar to our investigation of these I and j vectors. If you remember, we had just done that in our previous video. I and j in time will change into a new location to I and j. What we had in that type of investigation is that I and j are unit vectors. They are not changing their magnitudes. But in this case, we will have a change of magnitude as well when we investigate these two vectors, x omega and x dot I. Obviously, x dot information's time derivative will not change. It will be equal to 0. X double dot is defined as 0. But I direction will change, right? Because of that, we're going to have a time derivative part for this term. For this term, omega is constant, but x is not constant. X dot is defined, so we're going to end up with a change in the magnitude, and the change of the direction will happen because there is this omega and this frame is rotating. Therefore, j dot will also appear. So let's take a look at this drawing to understand these better. There's our two vectors. This is the v relative part. This is our x omega part. In the next instant, there will be d theta amount of rotation for these two vectors, and then the magnitudes might change. The change of the magnitude of x dot will be in the x direction. However, x double dot is defined as 0, so we don't have a part like that here. However, the direction is changing, and the direction change is defined as d theta, but we will have x dot because this vector is not a unit vector, its magnitude is x dot. So this change here of x dot is x dot d theta, and it is in the j direction, it is in the y direction. So there is x dot d theta as a result of that. we are taking a look at the change in the velocity of A, by the way. So these are the change vectors, changing vectors. And then there's the directional change of x omega part of the VA, dVA, and this is x omega, this is the magnitude times d theta, this is the arc length, and this is assumed to be a straight line at that instant. X omega d theta, it's in the negative I direction. So x omega d theta in the negative I direction. And then because of the change of the magnitude, and the magnitude change is only due to the change in x, change in omega is equal to 0 as we have defined it in that way. So we have omega dx in the j direction because of the change of the magnitude. Now, if we divide this both parts of the equation by dt, as we have done in similar things, similar procedures previously, then we end up with this acceleration of A information because we divide this dVA by dt, and the resultant is the acceleration of A is x dot omega, we will have d theta over dt here, plus omega dx over dt is x dot, so we're going to have 2 times x dot omega minus d theta over dt will be omega. Omega times omega is omega squared. We have x omega squared in the I direction with a negative sign. And these are the results of 2 omega cross product V relative plus this term, which is the centripetal acceleration, if you remember. And we call this part as the Coriolis acceleration. And the reason that we are calling it Coriolis is because of the name of the scientist that had discovered this. So the first letter is a capital letter as a result of that. Coriolis. Centripetal remains as a small cap because it's not the name of somebody else. So we have the centripetal acceleration and Coriolis acceleration terms in this example. We can investigate the same thing from our equation. Acceleration, absolute acceleration of B point, in this case happens to be O point, is equal to 0. Okay, because O point is a stationary point right over here. Then we have alpha cross product R. Alpha is defined to be 0 because omega dot is defined to be 0. So this part cancels out. And then we have this A relative term. And the reason that it is equal to 0 is because the magnitude of this V relative, which is x dot, is constant. So x double dot is equal to 0. So this part cancels out because x double dot is equal to 0. So we are left with these two terms, the centripetal acceleration and the Coriolis acceleration. So this is, again, a way to check if we are doing something right. And this is the foundation of this Coriolis acceleration, how we can derive this Coriolis acceleration by different means.